Hi guys, as I said, my name's Eric Nulton. I'm a virtual operations coordinator for Penn State University. I also do a lot of BIM integration consulting with various owners. Some of you, just to kind of get a feel here, how many of you have used BIM before or are very familiar with it, and how many of you guys are starting? So how many experts in the room that have used it extensively? Okay, a few. What about people that are just new that haven't used it yet? Okay, so we've got a pretty good mix of both. What I wanted to present this case study here. It's going to be a very quick overview of one of the longer projects that we've had that we've done BIM. And why I chose this is it kind of showcases us through our entire transformation of being a BIM implementer. When we first started on this project, we really had no understanding of BIM. We heard it was great. We heard there's a lot that it can do for us, but that was about all we did. All we knew. And we really fumbled through the first phase of it. When we got to the second phase, we were much more skilled with BIM, and we're actually delivering one of the more sophisticated BIM projects in the nation with it, all in the course of a few years. And that's kind of what I'll document a little bit. A little bit of background about Penn State. For a European college, we may not be that old, but for an American college, 1855 is a fairly old and established university. We're also one of the largest. Collectively, we have 24 campuses across the state of Pennsylvania, totaling almost 2,000 buildings and 30 million square feet that we have to manage. So we have an extensive building inventory that we have to keep up to date, keep safe, and keep running for all the students. Over the past about 4 years that we've been doing BIM, we've done many projects. We've done sophisticated research labs, we've done general offices, classroom buildings, hospitals, even utility plants and things like that. We've done pretty much all of it. The two that I'm going to highlight today, though, is what we call the Henderson Bridge and Henderson South project. So while there are two projects, essentially we kind of view it as one project in two phases. The first is the biobehavioral health section of it. And it's about a $48 million, 93,000 gross square feet facility. And this was intended to be the new base of our Health and Human Development College on campus. The second phase is our actual Health and Human Development building. And this is slightly larger. It involves both a renovation and a substantial new building component. And this is, the second phase is actually still going on. We're in construction now, but we haven't completed it. At the very beginning, when we started the first phase, we really, again, didn't have a lot of knowledge or understanding with BIM. We work very closely with our academic side, and the academic side developed the BIM Project Execution Planning Guide. And I don't know if any of you guys are familiar with it. It is considered one of the standards in the US for BIM planning. So we really started to take this and work with this and develop it into our own guide for our facilities. So with that, we brought some of the academic individuals in, some of the professors that were experts in BIM at the time, to help us kind of plan. And we set together some very basic BIM uses for the first stage. One of them, just basic design authoring. And if you guys are familiar with that, it's just modeling in 3D using Revit or Bentley or any of the other softwares. But this is really one of the first times that we've done it extensively and required it. The second major BIM use we used was design reviews. And we really started to see some benefit here because we found, being on the facility side, that a lot of people who don't work construction have difficulty visualizing a 2D drawing and seeing what it's going to be in 3D. So we were able to take some 3Ds and just some very basic models and walk a lot of the future occupants through these buildings and get a lot more feedback than we typically would doing 2D plans. So we really started to see some benefit with that. We also tried construction coordination for one of the first times. And this was a major headache. If any of you guys have done it and this on your first project, it is a lot of work that you typically don't anticipate. As you start to plan for it, you can start to optimize that process. And in the end, it saves a lot of time. But we started construction coordination for this project, and it really set us back a few months because we would be coordinating almost every day trying to get this model working. But it was still obvious that a lot of the members didn't understand the full intent of coordination. They wouldn't always model things exactly the way they needed to be for the coordination process to work. And it really slowed things down until we started to get the hang of it. And the last major use we did on this first phase is architectural renderings. And again, I'm sure most of you guys have seen this or are familiar with that. And again, we saw a lot of benefit with that. The renderings, we're really starting to focus a lot on them now is because it replaces a lot of physical mock-ups. We haven't eliminated physical mock-ups, but some of these renderings provide us with a lot of benefit there for low cost. So with that, and again, we really stumbled through some of those. Everyone was learning. The architect they had done some modeling before, but they didn't do a full integrated BIM process. It was a construction management project. They were all new. All the subcontractors were fairly new with this BIM concept. So we ran into some issues, and we'll discuss some of them here. One of the major ones was just model tolerances. We think, we designed this model, everything's perfect. Well, we started to realize that on certain elements, we couldn't always treat it exactly as perfect. There's a lot of variations when things are built in the field. So we would have something very well coordinated on the computer, but if the person installing it is just slightly off, it would lead into problems. So we failed to account and put the appropriate clearances on some things. And that resulted in us having to lower some ceilings, make some modifications in the field, which we would have preferred to avoid. But we started to learn that. Another one of the big challenges we encountered was just basic modeling errors. In the first phase, a lot of the design was done still traditionally on 2D, and then in construction we took it to 3D. The problem with that is we did encounter some errors because the designer wasn't the one doing all the modeling. We subcontracted that out, and we still do that on a lot of projects just because Penn State's in a very rural area. We don't have quite the technical capabilities as a large metropolitan area does. So we sometimes do need to sub that out. But you have to watch that very closely because if you have a modeler who doesn't quite understand the building systems, you can run into some problems. And that's what we ran into here. There's just some inadequate communication. And we also lacked a lot of decision makers in the coordination process. We also quickly learned that if you have a young tech guy at these BIM coordination meetings, you also have to have a senior engineer or somebody that can make design level changes on the fly. So once we started to work that out, the project went much faster. And even though we did struggle through this first phase, we did get some very good benefits from it. First, we identified a lot of conflicts between systems that we wouldn't typically do. And it's very hard, as Claire said, to get accurate data on how much BIM saves. But this is one of the areas where we can get some type of estimation on it. And by eliminating some clashes that we knew we would encounter in the field, we save probably between $100,000 and $300,000. So on a $40-some million project, it's not major, but it saved some. And these were just the major systems. We still coordinated a lot of other things that provided savings. We were able to do advanced hanger and bang-it placement, which reduced the time for mounting the hangers by about 60%. And the way we found that time was because in our scheduling, we scheduled like we would traditionally, where you go, walk out, mark it, drill for the bang-it placement, and then mount everything. But by using BIM, we were able to reduce that and put all the bang-its and things in before we poured the concrete, and that saved us a lot. We also did a lot of prefab with the HVAC system, and that also reduced time by approximately 60%, and that was because we estimated the time doing it traditional methods. So when we got to phase 2, we started to see there is a lot of good benefits from BIM. And at this point, we've had many more projects under our belt. So we approached it from a more comprehensive plan. And I won't get a lot into the details. I think I'm running out of time here. As you can see, we have a actual BIM uses chart. And we do a lot more BIM uses there. Some of the key things that we started to do on this phase though, is we really started to design for maintenance. BIM really enabled us to start to look at things and improve that collaboration and communication between the designer, the contractor, and our maintenance technicians. We found that a lot of times our maintenance guys who are responsible for these buildings at the end really had no say in these projects beforehand. So what we really started to do is bring them into these 3D models, and we would walk our maintenance engineers and our technicians, the people that actually turn the wrenches, walk them through this. And it's amazing how many changes we get. We'd have them reorienting pipes and pumps and all these things. Yes, they met code before they technically would have worked, but our guys are experienced in maintaining these systems where the designer typically isn't. So we got a lot of very good information that is going to save us a lot of money in maintenance down the road for next to no cost. We also started to focus some more on aesthetics. Penn State's very fortunate because we do have an academic side, and we actually have a military research labs on our campus too. And one of those military research labs, they have an immersive cave. And are you guys familiar with any type of cave environment? Essentially, there's these rooms that you can walk in and you're completely enclosed, the ceiling, all walls, but it projects the model onto it. So you have 3D glasses that actually track your movement, and it's like you're walking through the building. And this costed some money. It wasn't a basic Navisworks model that we did for maintenance coordination. But here it cost us about $5,000 to $10,000 to get this model. We took the Revit model and put it into various gaming engines and rendering software so that we could have a really high fidelity, clear model. Then when we did that, we were able to bring a lot of our vice presidents and the people who, again, don't really understand the technical side but are worried about the aesthetics, walk them through these areas, the high profile areas, and get their feedback. And from doing that, again, for a cost of $10,000, we decided that we needed to change a lot of the paneling in the building. That was pushing a $500,000 change there, but we did it early in design, so it didn't cost us anything. We had to change all the glass railings there. A lot of people felt insecure about having clear railings, so we made them more opaque, and we added handrails to that. Again, all these things we were able to do for no cost or next to no cost because we did it very early on in the project. And if we would have changed it once it was constructed, it would have been extremely expensive. So we considered that money very well spent. We also did a full design coordination. And where this differs from a lot of people is we had the designers working with the construction team the whole way through. And we actually coordinated this model twice. And what that did is it really helped the construction team be able to use the model. And it really is reduced a lot of the construction coordination efforts and errors. And last, this is what I tend to focus on mostly, is asset information. Everyone talks about COBE and all these great systems, and you push a button. If any one of you have done it, it doesn't work that way. It takes a really detailed process, and this is what we really focused on this project. We developed an information exchange for Penn State that actually is being adopted by a lot of other organizations around the country now that differs from COBE. But it's a very similar concept. Basically, we developed one for our needs. But with that, we're able to track all of our asset information the whole way from design till the building's handed over. And we're really starting to use that information so all project team members get a value out of it. So for my closing points, basically, if you guys are just getting started with BIM, experience isn't necessary. It definitely helps, but if you're willing to, work on it, and you have a tolerance for some mistakes and a learning curve, anyone can do BIM without any experience. The planning pays dividends. Everybody loves to focus on software. Oh, I bought this software, or I'm using this standard, or something like that. But really what is the most important is the planning of BIM. BIM is not a technology, it is a process that's enabled by a technology. So you really have to start doing some planning and there's a lot of guides out there to help you with that, and that's where you see the big savings. Again, communication is the key. BIM enables communication. It helps people talk to each other, share information much better, and that reduces cost. And we've seen a lot of benefits from that. And last, again, you'll always have trouble seeing hard data on exactly what BIM saves. We know it saves it. I mean, we've done it on pushing about $1 billion worth of projects now, and that's going to grow. We've seen such savings in it that we require it on almost all of our projects now. So there is a savings. It's just very difficult to quantify, but everyone that does it, they do see a lot of savings in there. So with that, I'll open myself to questions. Go ahead.
Okay, so you mentioned savings of around 100 to 300k on that project.
Yes.
Have you worked out roughly how much you invested in the BIM technology?
On the first phase, we didn't really pay anything for BIM. Sometimes we'll pay for services, but we are a large enough owner now that we don't have to really pay for BIM. We say this is part of the standard process now. There are added services that we pay, like when we do the advanced modeling, we have to basically sub out hire out the lab, have them manage it, so there's added cost for that. Some of our deliverables, we want what we call an as-maintained model, so at the end we have a few different deliverables that are different from most people, and one of them is a Revit style model that shows as-built conditions. We consider that extra work, so we do pay an added fee for that. But most of this, we don't pay anything more anymore.
Just push it on the supply chain.
But
yeah.
we've pushed it, we've been big enough, and everybody is seeing savings in it now, so we're seeing reductions. I mean, everybody, the architect, contractors, they're all on board with this now. Once they do a project or two with us, they see that it has saved them a lot. Again, it's hard to quantify some of those numbers. I saved that. Those are just from a few identified clashes, some of the major clashes that we found. But you're constantly rerouting things during coordination, so you're saving a lot of these things that you just don't even know, that aren't even aware that it's going to be a clash. So it's very hard to quantify that, but I hope I answered your question.